welcome to our deep dive. You sent us quite a collection of material on sensation, textbook chapters, academic papers, all sorts of things. Seems like you're ready to really unravel how we perceive the world.
It really is fascinating, yeah. Everything from, those sensory receptors firing off to how the brain puts it all together. It's amazing.
One thing that really jumped out at me was this quote from A. Jean Ayres talking about how if all the sensory stimuli that enter our central nervous system were just allowed to bombard the brain, we'd be completely ineffective. It's like our brain is a nightclub bouncer.
Yeah, it really is filtering out all that noise. But sensory integration, it's not just about filtering, right? It's got to organize and integrate that information to create meaning. It's really the foundation of how we learn, how we move, how we interact.
So sensory integrity, is that the term for how well our brain is handling all that information?
Exactly. And when that integrity is compromised, it can have a ripple effect on everything someone does every day. Take diabetes, for example.
Oh, interesting.
Nerve damage from high blood sugar can actually reduce sensation, especially in the feet. Something as simple as walking can become risky. It increases the chances of falls or injuries.
Wow, that's a great example of how something we really just take for granted. Our sense of touch, how important it is. And speaking of how our bodies are wired, the source material talked about dermatomes and myotomes.
Right.
What are those again? Remind me.
We'll think of them as maps of the nervous system. So dermatomes, those represent areas of skin that are all supplied by a single nerve root. And myotomes, those represent groups of muscles controlled by a single nerve root. So clinicians, they use these maps as really essential tools to pinpoint, where a neurological problem might be.
That makes sense. And the source material actually mentioned that there are slight discrepancies between some of the published dermatome maps, which is kind of wild, right?
Yeah, and it makes you wonder how much variation there is from person to person.
Exactly, yeah.
While the general patterns, they tend to hold true, there can be subtle differences. So it really highlights the complexity of the nervous system and, it really stresses how important a thorough exam is.
Oh, absolutely. And speaking of exams, the source material actually walks us through a typical sensory evaluation. And it seems like a lot more than just, can you feel this?
Yeah.
It's more in depth.
Yeah, a lot more to it. Before diving into specific tests, therapists start with preliminary assessments. Things like arousal, attention, orientation, even cognition, just to get a baseline, right?
Oh, okay, that makes sense. You want to make sure that they're with you
Exactly.
before you start asking them to feel subtle sensations. The source material even lists examples of those attention tests, and some of them are, I don't know, like counting backward from 100 by sevens.
That's a tough one.
I can't imagine trying to do that while also concentrating on some kind of sensory task.
Yeah, it really tests, mental flexibility, processing speed, things that can be affected by neurological conditions. The source also talks about using proverb interpretation.
Oh, proverb interpretation. Interesting. How does that work?
Well, you present the patient with a proverb, like, don't count your chickens before they hatch.
Yeah.
And you ask them to explain the meaning. So it taps into abstract thinking and comprehension, gives you a good sense of their cognitive abilities.
So it's not just, can you feel a pin trick, but can you understand a deeper meaning? That's so interesting.
It really highlights how connected those systems are, sensory and cognitive.
Absolutely.
And to really understand how we perceive the world, we need to look at the building blocks of sensation, those sensory receptors.
Now we're getting to the nitty gritty. And the source breaks down sensory receptors into three main categories, right? Superficial, deep, and combined.
You got it. Superficial receptors. Also known as exteroceptors. Those are located in the skin and subcutaneous tissues. They detect things like temperature, pain, light touch, and pressure.
So those are the ones that tell us if our coffee's too hot or our bed is too soft.
Exactly. And then there are deep receptors, or proprioceptors. Those are located in our muscles, tendons, ligaments, and joints. And those are all about body awareness. They tell us where our limbs are in space.
Proprioception. That one is always so fascinating to me. It's like our own internal GPS.
Think about how crucial that is for, coordinated movement. We can type on a keyboard or swing a tennis racket without even thinking about where our hands are.
It's wild. It's all working behind the scenes. What about those combined receptors? What are they all about?
Well, they integrate information from both superficial and deep receptors, as well as input from higher brain centers. And they're responsible for more complex sensations like stereognosis, two-point discrimination, graphesthesia.
All right, time for a vocabulary lesson. Stereognosis. That's the one where you can identify an object by touch alone, right? Like reaching into your bag and you know you're grabbing your phone.
That's it. And two-point discrimination is the ability to distinguish between 2 points touching the skin. So it tells us how sensitive different areas of the body are.
So, like, my fingertips are probably much better at two-point discrimination than my back.
Exactly. And graphesthesia, that's the ability to recognize numbers or letters traced on your skin. It's pretty cool.
It is cool. It's like a secret code. Wow, our sensory system is way more sophisticated than I ever realized. It's crazy how much is going on that we're not even aware of.
Yeah. And all of this information travels to the brain through these intricate neural pathways. That's a whole other conversation. Maybe that's a good place to pause.
Yeah, we covered a lot. Sensory integration to all those different receptors. We'll pick up the journey in part 2 of our deep dive.
Welcome back to our exploration of sensation.
Last time we left off talking about those pathways that carry all the sensory information up to the brain. Like a whole network of highways and back roads, all leading to these different processing centers.
And just like a transportation system, different routes for different kinds of information. The source material highlights two main pathways, the anterolateral spinothalamic tract
Okay.
and the dorsal column medial lemniscal pathway.
Those are a mouthful.
Yeah.
But I remember from the reading that they carry different types of sensations.
Yeah, that's right. Think of the spinothalamic tract as the express route, right? For pain, temperature, crude touch, fast acting system, designed to alert us to danger.
So if I accidentally touch a hot stove, that signal's going to zip right up that spinothalamic tract.
Exactly.
Letting my brain know, hey, pull your hand away.
Right away.
Quick.
Exactly. The dorsal column pathway, that's more like a scenic route. Carries information about fine touch, vibration, proprioception, gives the brain, more detailed data, more nuanced.
Interesting. So the spinothalamic tract's like, hey, quick alerts.
Yeah.
And the dorsal column is like, okay, here's the high definition picture.
Yeah, that's a good way to put it.
Both essential, though.
Absolutely, yeah.
Yeah.
To interact with the world safely and effectively.
All this sensory input eventually reaches the brain, but where exactly does it go? The source material mentions the sensory homunculus, that little map of the body in our brain.
Right, the sensory homunculus. And it's not just a map, it's like this dynamic representation of our body's sensory landscape, constantly being updated, as we interact with the world.
Wow.
It's located in the somatosensory cortex, a part of the brain that's dedicated to processing all of that touch, temperature, pain, proprioception.
And the size of different body parts on the homunculus reflects their sensitivity, right? Like I remember the readings mentioned that our hands and face have a much larger representation than our torso.
Yeah, and what's really fascinating is that the sensory homunculus isn't fixed.
Yeah.
It can actually change over time based on our experiences, based on learning.
Really?
Yeah, so for example, musicians, they practice extensively.
Right.
They develop larger representations for their fingers, reflecting that heightened tactile sensitivity.
So it's not just how many sensory receptors we have in an area, but how much we use them that shapes this map.
Exactly. It highlights the brain's amazing plasticity, its ability to rewire itself in response to experience.
That makes you wonder how much we can actually influence our own sensory perception just through, training and practice.
And that's a question a lot of researchers are really exploring.
Wow.
The implications for rehabilitation are pretty exciting. If we can understand how the brain reorganizes, we might be able to come up with even better, more targeted therapies.
That's incredible. But let's get back to those sensory exams we were discussing. The source material goes into detail about how clinicians actually assess all these different types of sensations.
Yeah, it really is like detective work.
Oh, interesting.
Using these tests to piece together an understanding of a person's sensory abilities. We talked about some of those preliminary cognitive assessments, but let's dive into the specific sensory tests.
I'm ready. Behind the scenes of a neuro exam.
So we'll start with some basic sensory modalities, things like touch, pain, temperature, vibration. For touch, they might use a cotton swab or a soft brush, to assess light touch perception. For pain, a safety pin or a broken tongue depressor
Oh, interesting.
to test sharp, dull discrimination.
So it's really about determining if someone can, like, reliably detect and interpret the stimulus.
Yeah. And the clinician is watching for the pattern of any loss.
Hmm.
Is it localized to a certain area or is it more widespread? Helps them narrow down the
So
cause.
it's not just check, check, check. It's like gathering this detailed information
Exactly.
about the type and the severity,
Right.
location.
Exactly.
What about those deep sensations we talked about, proprioception and kinesthesia? How are those tested?
Okay, so for proprioception or joint position sense, the clinician might move the patient's limb into a position and then ask them to, mirror that position with their other limb. For kinesthesia, the awareness of movement, they might passively move the patient's limb and ask them to describe the direction, up, down, left, right.
So you're testing the brain's ability to track the body's position and movement even without seeing it.
Exactly. And for vibration, they'll use a tuning fork.
Okay.
Strike it to make it vibrate and then place it, on a bony prominence, like the wrist or ankle. Ask the patient to report when they feel it and when it stops.
It seems like these tests are designed to, really tap into all the ways that we experience the world
Yeah.
through our senses. But what about those more complex sensations, like stereognosis, two-point discrimination, graphesthesia? Those seem harder to assess.
You're right. Those combined cortical sensations are a little trickier. For stereognosis, they might place a familiar object in the patient's hand and ask them to identify it without looking, like a key or a coin.
That sounds fun, but it's really testing high-level brain function, right?
Absolutely. It involves touch, spatial awareness, memory, even language.
Wow.
Two-point discrimination, the clinician uses a special tool called an aesthesiometer. It has 2 points that can be adjusted, closer or farther apart. And they touch the patient's skin with both points and ask, can you feel 1 point or 2?
So the closer those points are, when the patient can still feel two distinct sensations, the better their discrimination is.
Exactly. And as we talked about before, different parts of the body have different levels of sensitivity. Our fingertips are incredibly sensitive, right, for all those tasks that need fine motor control.
Makes sense. We need that for writing, playing music.
Exactly.
Oh.
For graphesthesia, the clinician uses a blunt object, like the eraser end of a pencil, and they draw, like, a number or letter on the patient's palm and ask them to identify it.
So it's like a tactile version of reading. It's amazing how much the brain can do with just touch.
It really is.
So all of this information that's gathered during the sensory exam is used to create this, comprehensive picture
Exactly.
of the patient's
Some
function.
neurological function.
It's been so insightful. It really feels like we've gone on this guided tour of the sensory system, from the receptors to the brain.
Now that we have a grasp on how information is gathered and assessed, we can really get into sensory processing, how our brains make sense of it all.
Yeah, and how it guides our actions.
That's a great point.
That sounds like a great place to pick up in part 3 of our deep dive. Welcome back. We've been on this incredible journey through, the world of sensation, from those receptors in our skin to those pathways that carry all that information up to the brain.
And now we get to, the grand finale, sensory processing, where all those little bits of data actually transform into meaningful perceptions and actions.
It's like we've been looking at the hardware, and now we're finally getting to the software.
Yeah, the operating system that makes it all run. Sensory processing is what allows us to make sense of the world. It's how we take all those sights and sounds and smells and tastes and textures and turn them into one coherent experience.
So it's not just about feeling the warmth of the sun on your skin. It's about understanding that it's a sunny day and maybe, going for a walk.
Exactly. It's about filtering, organizing, integrating all that sensory input to create this internal representation of the environment. And it's not a one-size-fits-all process either.
Right. The source material mentioned how sensory processing can actually be a challenge for some people. They might be oversensitive to certain sensations or undersensitive to others.
Exactly. Individuals with sensory processing differences, they experience the world in unique ways. Some might find certain sounds incredibly distracting, like the hum of a refrigerator, while others crave intense movement, always seeking out swinging or spinning.
Wow, that's so interesting. It really highlights how there's no one right way to perceive the world.
Absolutely. These differences, they're rooted in neurological variations. It's not just a matter of, choice. And these differences can have a huge impact on a person's daily life.
I can imagine. Yeah, it could affect everything, right? Social interactions, learning, emotional regulation.
You're right. A child who's hypersensitive to touch might find clothing tags unbearable or avoid hugs. Someone who's hypersensitive to movement might need to constantly fidget or sway just to stay focused.
It sounds like sensory processing differences can create a lot of challenges, but the source material really emphasized how important early identification and intervention is.
Yeah, early intervention is key. There are therapies, strategies, all kinds of things that can help people learn to manage their sensitivities, help them develop coping mechanisms.
So there's hope, there's help available.
Absolutely. And the more we understand about sensory processing, the better equipped we are to support everyone.
This deep dive has been amazing. We've learned so much. How our bodies gather information, how clinicians assess those abilities, how our brains make sense of it all. It's truly fascinating stuff.
And now you have a deeper appreciation for how your senses shape your experience of the world and how crucial sensory processing is for everything we do.
It really is. And for those struggling with sensory processing challenges, remember, there's help. Keep learning, keep advocating, and keep seeking support.
Think about how adaptable the sensory system is and how it can even compensate for loss or injury. How can you support your own sensory health? How can you optimize your experiences? That's something to think about.
This has been an incredible deep dive into the world of sensation. Thanks for joining us.